It's October 27th, 2025. In just 48 hours, 3I Atlas will disappear behind the Sun, and when it does, the world will lose sight of the most peculiar interstellar object ever recorded. For weeks, astronomers have tracked its fading signature, a faint blue-white body venting nickel vapor, tracing a low-inclination retrograde path that defies statistical probability. Its next appearance is scheduled for December the 15th, the date when Earth, the Sun, and this object align almost perfectly along one plane. No one can yet say what that alignment means. For NASA, ESA, and independent observatories, it's a waiting period filled with silence and speculation. For others, it's the most delicate phase of an unfolding mystery. The moment when something either proves itself natural or reveals it was never a comet at all. The question is no longer what it is, but what happens when it comes back. Because when 3I Atlas re-emerges from solar conjunction, every telescope on Earth will be watching, and what it does next could redefine the limits of what we call natural. And that's where the real story begins. When 3I Atlas was first logged by the Pan-STARRS survey, astronomers thought they had another comet, an icy fragment from the interstellar dark, a frozen traveller carrying the fingerprints of another sun. It fit the initial profile: faint, fast, slightly elongated, tumbling across the starfield at a velocity too high for the Sun to have birthed it. The community classified it quickly, almost reflexively. Interstellar Visitor Number 3. The naming conventions were procedural. The excitement was cautious. After all, we had seen this before with Oumuamua in 2017 and Borisov in 2019. But what no one expected was that within weeks, 3I Atlas would break nearly every rule written about how comets behave. The first hints came from spectroscopy, the science of decomposing light into its constituent wavelengths to determine composition. When an object emits or reflects light, atoms within it leave telltale barcodes, narrow lines that reveal which elements are present and in what states. For ordinary comets, these lines are predictable: hydrogen from water vapour, carbon from organic compounds, oxygen from CO and CO2, and the faint green of diatomic carbon that paints every textbook image of a comet's coma. But the initial spectrum captured by the Subaru telescope in Hawaii showed something else entirely. The dominant feature was nickel, pure nickel without its usual companion ion. The detection was so unusual that the instrument team spent 3 nights recalibrating their gratings, convinced it was a ghost signal or a detector artifact. When the data held steady, they sent it to the European Southern Observatory for independent verification. The Very Large Telescope in Chile confirmed it. The emission lines near 341 and 347 nanometers were unambiguous. Nickel vapor, radiating at intensities far exceeding anything observed in a cometary coma. Nickel is not supposed to sublimate in open space. Its boiling point is nearly 2,900 degrees Celsius. Temperatures achievable only inside furnaces or near the photosphere of a star. At 3I Atlas's current distance, solar heating could, at best, warm the surface to 500 degrees Celsius. That is enough to liberate CO2 or methane ice, but not metal. Yet the spectral evidence was relentless. Each rotation of the object brought a repetition of the same nickel signature, stable in both intensity and wavelength shift, implying a continuous process rather than sporadic flares. Then came the second shock. Embedded within those nickel lines was a set of weaker features matching the molecular structure of nickel tetracarbonyl, NiCO4, a toxic compound familiar not to astronomers, but to industrial chemists. On Earth, nickel tetracarbonyl forms when nickel dust interacts with carbon monoxide gas under moderate pressure at 40 to 60 degrees Celsius, conditions found in chemical reactors, not in cosmic vacuum. It decomposes explosively above 200 degrees Celsius. To detect it in an interstellar object was, by all practical reasoning, impossible. And yet, the pattern recurred in data from Keck, Gemini South, and even the infrared spectrometer aboard the James Webb Space Telescope before conjunction. The cross-correlation matched within 0.03 angstroms. This was not a false positive. Something aboard or within 3I Atlas was producing nickel tetracarbonyl, or at least its optical signature, in quantities large enough to register across millions of kilometers. At that point, explanations fractured. One camp proposed that micrometeorite impacts were exposing subsurface metallic veins, allowing trapped carbon monoxide to react transiently with nickel grains. But that hypothesis required an implausibly high impact rate to maintain the observed flux. Another argued that the emission was simply reflective, scattering from a nickel-rich crust, not true outgassing. Yet the Doppler profiles showed velocity broadening consistent with gas expansion, not reflection. The line wings told the story, molecules moving outward at hundreds of meters per second, not static metal glinting in sunlight. More disquieting still was the absence of everything else. There was no measurable water vapour, no hydroxyl band, no cyanide, no sodium tail. Even the ubiquitous green carbon line was missing. The coma, faintly visible in long exposure imaging, glowed pale blue-white rather than emerald, a hue driven by metallic ions, not organic gases. Whatever 3i Atlas was venting, it was bone-dry and eerily clean. This created an uncomfortable contradiction. If it were metallic, it should behave like an asteroid, inert and light-reflecting. If it were volatile, it should be spewing water and carbon chains. Instead, it was doing both and neither, venting nickel molecules as though they were gas while maintaining a steady albedo that barely changed with distance from the sun. It was, in thermal terms, self-regulated. Researchers at A Coruña University attempted to simulate such behaviour using high-temperature alloys. Their model required a surface layered with nickel-iron silicate crust under carbon dioxide-rich pockets. When sunlight struck, the CO2 would expand, driving jets through metallic fissures and carrying vaporized nickel with it. The numbers matched the emission strength but failed the stability test. No natural structure could repeat that venting pattern with such regular timing. Because the venting was timed. Over weeks of monitoring, the nickel lines pulsed in brightness every 11 hours and 46 minutes, aligning with the object's rotation. Yet smaller fluctuations occurred on sub-periodic scales, tiny modulations of 0.2% amplitude repeating every 73 minutes. Too regular for random vent bursts, too weak for instrumental noise. The effect looked, in the data, like a heartbeat. Regulated flares, one researcher called them during a closed-door panel at ESA. The phrase leaked onto an internal forum and spread quickly. Within days, speculation escalated from geology to guidance. It didn't help that earlier interstellar visitors, Oumuamua and Borisov, had already strained our definitions of natural. Oumuamua's non-gravitational acceleration, still unexplained, had opened the door to theories of thin film propulsion or solar sails. But 3i Atlas was bigger, brighter, and more cooperative to instruments. Where Oumuamua had left ambiguity, this one left precision, too much of it. NASA's public statements remain disciplined. No evidence currently supports non-natural origin. But internal language, uncovered through research collaboration archives, was less confident. One memo from a Goddard Astrophysics division read, "Persistent near-mission suggests non-equilibrium chemistry inconsistent with standard cometry processes. Further investigation warranted." Another, from the Infrared Science Group at JPL, noted, "Formation of NiCO4 implies closed system recombination pathways. Such processes typically require containment or catalytic structuring." In plain language, to make what they were seeing, you usually needed a chamber, a vessel. Even those unwilling to entertain artificial scenarios admitted that 3i Atlas demanded new chemistry. Some invoked cryogenic metallurgy, theorizing that at interstellar temperatures, nickel atoms could bind weakly to CO molecules within amorphous ice matrices, later releasing them as the matrix warmed. Others proposed an electrochemical mechanism, an internal charge differential creating localized heating zones that vaporized trace metals. But those models raised more questions than they solved. What maintained the electrical potential? Why nickel, not iron? And why so consistent a ratio over months of observation? Across astrophysics, ratios matter. Nature produces variety, machinery produces uniformity. In every spectrum taken of 3i Atlas, the Nephi ratio remained locked near 12 to 1 plus or minus 0.3. No comet, asteroid or planetary fragment shows such constancy. It's as if someone, or something, designed the mixture to stay fixed, no matter how much material was lost. Thermal mapping added another layer of intrigue. The JWST mid-infrared instrument measured localized hotspots up to 900 Kelvin, while adjacent regions stayed below 250 Kelvin. That's a differential of 650 degrees across less than 15 kilometers, a gradient difficult to sustain without internal insulation or energy control. Some compared it to the thermal management of spacecraft hulls, regions designed to vent heat deliberately while keeping others cold. But again, that comparison was quietly discouraged in official papers. Then came the CO2 dominance. Every comet venting that much CO2 relative to H2O behaves erratically. Its jets shift unpredictably as ice pockets burst. 3I Atlas, however, showed a smooth, stable flow rate. Its coma expanded evenly, as though the gas were being metered. The result was a soft, uniform halo with none of the chaotic plumes typical of CO2-active comets. When computer models simulated random CO2 sublimation, the output brightness varied by 30%. The observed variation was under 2%. Either we had found the most isotropic natural emitter in recorded history, or an object that corrects its own imbalance. By late September, the global picture was unsettling. We had a body roughly 60 kilometers across, metallic yet venting, chemically impossible yet internally ordered. It was bright where it shouldn't be, and quiet where it should roar. Every instrument pointed at it agreed on one thing: it was coherent. Stable composition, stable light curve, stable anomalies. For the skeptics, this was merely an extreme case of cosmic coincidence, a lump of mineral luck formed in a bizarre system. For the more speculative thinkers, it was something else entirely. Perhaps debris from an engineered process, or a derelict vessel whose internal chemistry had outlived its makers. The debate split conferences into factions. Words like artificial or technogenic never appeared in print, but everyone knew they were being whispered. In truth, the instruments cannot tell intent. Spectroscopy sees emission, not motive. Telescopes record photons, not plans. Yet the pattern, regular, symmetrical, repeatable, kept hinting at an unseen logic. Each explanation patched one inconsistency while exposing another. The result was a riddle wrapped in data, order emerging from what should be entropy. And here lies the crux of the enigma. If 3I Atlas is natural, it's a window into processes we've never witnessed. Metallurgy in space, chemical systems operating like machines. If it isn't, then we may be staring at relic engineering, a monument drifting between stars. Either answer forces a redefinition of what natural even means. Because the signature of 3I Atlas is not chaos, it is precision. Its chemistry speaks in ratios, its heat in pulses, its light in rhythms. It behaves less like a rock and more like a system maintaining equilibrium. And if there is one thing the universe rarely does on its own, it is balance. That balance will only become harder to ignore when we turn from what it's made of to how it moves. The deeper astronomers studied 3I Atlas's motion, the more it began to feel deliberate. Its path through the solar system did not resemble the chaotic slingshots of other interstellar wanderers. It moved almost as though it knew where the planets were, as though its timing had been quietly rehearsed long before it arrived. When its orbit was first plotted, nothing appeared extraordinary. A faint, fast-moving speck crossing the inner system on a hyperbolic curve, typical of debris that had slipped free from another star. But as additional tracking data poured in from observatories across the world, the calculations started to reveal a pattern too precise for comfort. The inclination of its orbit was measured at just over 6 degrees relative to the ecliptic plane, the flat disk along which every major planet circles the Sun. Most interstellar visitors slice through that plane at steep angles. 3I Atlas, by contrast, was nearly parallel to it, as if it had merged itself into the geometry of our own solar system. The strangeness did not stop there. It was moving in the opposite direction of every planet, on a retrograde trajectory, like a swimmer cutting against a current that has carried everything else one way for billions of years. The odds of a natural object entering on such a path, both so flat and so perfectly retrograde, are microscopic. The combination suggests an approach vector tuned almost precisely to the Sun's motion through the galaxy. To reach that orientation by chance would require the object's origin velocity to counter our own, almost exactly, a cosmic coincidence of staggering unlikelihood. Mathematically, that precision left researchers uneasy. Simulations run at JPL showed that less than 1 in several million interstellar bodies should ever intersect the solar system with those parameters. Yet 3I Atlas was right there, gliding calmly along a course that seemed to weave through our planetary orbits like a thread through a loom. Jupiter, Mars, Earth, each lay along its route, each visited in sequence. On August 3rd, it crossed Jupiter's orbital path, narrowly missing the giant planet's position by mere days. In September, it swept through the orbit of Mars, this time less than 6 million kilometers from perfect intersection. And finally, the projections for December 15th placed Earth directly along the line connecting the Sun and the object, an alignment so close that from our perspective, they would appear to overlap. The geometry was exact to the second decimal. Most comets wobble and drift. Their jets fire unevenly, pushing them slightly off course each day. 3i Atlas showed no such deviation. Despite clear signs of venting, its motion followed a gravitationally perfect path, unbent by thrust or torque. Astronomers measured its acceleration to within 1,000th of a meter per second squared, and found nothing beyond what the Sun's gravity alone could explain. That kind of stability is rare even among inert asteroids, let alone a venting interstellar body. The deeper teams looked, the more patterns they found. Its observational windows, Mars in September, the Sun in late October, Earth in mid-December, were separated by almost equal time intervals, each roughly 45 days apart. When plotted on a timeline, those windows formed a repeating rhythm, a long pulse matching harmonic multiples of its rotation period. The cadence felt too neat, as if every phase of its journey was structured around when it would be seen. Of course, no one could prove intent from numbers. Geometry alone does not imply design. And yet, in the quiet data rooms of mission centers, the coincidence became difficult to ignore. The resonance between its motion, its visibility, and its rotation whispered of order, and scientists, even the skeptical ones, could feel that order pressing against their models. Some tried to ground the anomaly in physics. Jupiter's gravity, they argued, could have gently flattened the object's entry path as it was captured into the inner system. That explanation worked on paper, until simulations showed it couldn't flip an orbit into retrograde motion. Others appealed to observational bias, claiming we only discover objects near the ecliptic because that's where our telescopes look. But bias cannot explain the precision of the alignments, nor their timing with planetary positions. Each new data set only deepened the unease. When 3i Atlas passed Mars's orbit, the Mars Reconnaissance Orbiter briefly pointed one of its instruments toward the object's estimated position. What it saw, or failed to see, was never released publicly. But one line buried in a technical update referred to unanticipated thermal interference during external tracking. It was vague, almost meaningless, yet it fueled speculation that something more than reflected sunlight had been detected. Meanwhile, the object's orbital energy seemed curiously conservative. Most comets lose a measurable amount of velocity as they expel material. 3i Atlas's inbound and projected outbound speeds matched to within a fraction of a percent. No measurable energy loss, no random acceleration. It moved like a body under complete control of gravity and nothing else. Or perhaps under control of something that understood gravity very well. For dynamicists, this was both thrilling and infuriating. To match all observed parameters, retrograde motion, ecliptic alignment, stable energy, symmetric venting, required a degree of tuning that random natural processes rarely produce. Each new fit to the data reduced the range of possible explanations until the remaining space looked uncomfortably narrow. Still, the official statement stayed cautious. Chemically and dynamically atypical, but within natural expectation ranges. The language was deliberate, the tone restrained, but off-record among those running orbital integrators late into the night, the tone shifted. Some began to describe 3i Atlas's motion as programmed. Others compared its trajectory to reconnaissance flybys, smooth, calculated, indifferent to planetary gravity wells, yet always near enough to observe. The possibility of deliberate navigation was never printed in scientific literature, but it hovered around the edges of every conversation. It was in the pauses during briefings, the half-phrases in internal emails, the way researchers avoided saying artificial even when their models brushed against it. Whatever the truth, the numbers refused to relax. The trajectory was too efficient, the path too smooth, the coincidences too many. And as October waned and the object approached conjunction, one uncomfortable realization settled in. If this was coincidence, it was the most coordinated coincidence the solar system had ever hosted. On October 29th, 3I Atlas would vanish behind the Sun, slipping into a blind zone from which no telescope could track it. When it returned 6 weeks later, its path would tell the story. If it stayed true to prediction, the mystery would narrow toward improbability. But if it shifted, by even a fraction of a degree, the debate would erupt. Because a natural comet cannot change course in darkness. Until then, all anyone could do was wait. The orbit of 3I Atlas hung suspended in mathematics, perfect and untouchable, a frozen arc of probability winding through the solar system. And as Earth drew closer to that December alignment, one question echoed quietly through observatories around the world. What happens when perfection moves? The first time 3I Atlas crossed the orbit of a planet, most astronomers dismissed it as coincidence. Space is vast and intersections between paths are common. But by the third alignment, the pattern was impossible to ignore. Each encounter unfolded with uncanny precision, as though the object was tracing a route carefully plotted long before it arrived here. In early August, Jupiter became the first checkpoint. The gas giant's immense gravitational field has long served as a gatekeeper for the inner solar system, capturing comets, flinging asteroids outward, reshaping cosmic traffic for eons. Yet 3I Atlas passed through that region with remarkable ease, unperturbed, untouched, as if its trajectory had been mapped to thread between gravitational thresholds. At 0.6 astronomical units from Jupiter's orbital plane, it should have experienced measurable perturbations, slight but detectable. None appeared. Its velocity vector held firm, its course unaltered to within 3 decimal places. The event marked the first sign that something about its path was resistant to chance. Weeks later, attention shifted to Mars. By mid-September, the object's projected course placed it almost directly through the orbital track of the red planet, just 6 million kilometers from perfect alignment, a gap minuscule on astronomical scales. The Mars Reconnaissance Orbiter, the only asset close enough to gather direct data, received an urgent update from NASA's Jet Propulsion Laboratory, point instruments toward the incoming interstellar body during its pass. Officially, the results were inconclusive. No released imagery, no spectra, no mention in mission reports. But internal documents hinted at something unusual, a transient thermal anomaly that briefly overwhelmed the orbiter's spectrometer, as though a flare of energy had been emitted or reflected from the region of space where 3I Atlas was expected to pass. When those notes reached the European Space Agency, analysts began cross-checking timestamps against ground-based observations. The correlation was exact. The anomaly occurred within 30 seconds of the predicted crossing. Statistically, it was almost impossible for such timing to be random. The idea of a synchronized flash, intentional or otherwise, was quietly raised in an internal memo, then buried beneath layers of a cautionary language. After the Mars event, something began to shift in tone across the scientific community. What had been treated as an astronomical curiosity was becoming a logistical problem. Each planetary encounter offered data, but also deepened the unease. The object's flybys seemed too clean, too smooth. Jupiter, Mars, and soon Earth, all visited in sequential order, each near maximum visibility from one or more observation points. It moved as though following a route of opportunity rather than accident. The upcoming Earth alignment on December 15th became the focus of global attention. Orbital charts showed a nearly perfect straight line. Sun, Earth, 3I Atlas. The alignment wasn't just close, it was geometrically exact, within fractions of a degree. From our perspective, the object would appear to pass directly behind the Sun, then re-emerge along the same axis that links our world to the solar centre. Such a configuration happens rarely, and almost never with an interstellar visitor. The odds of that geometry repeating by chance within a century are vanishingly small. Astronomers prepared for it like an eclipse. Ground-based telescopes in Chile, the Canary Islands, and Japan coordinated observation windows. The James Webb Space Telescope adjusted its schedule to capture post-conjunction spectra as soon as 3I Atlas reappeared. Meanwhile, space agencies released calm, measured statements about routine monitoring and cooperative observation. But beneath the surface there was urgency. What the object did during that alignment, its brightness, its motion, any emission, would either settle the debate or blow it wide open. Every flyby so far had carried its own anomaly. During the Jupiter passage, there was the absence of gravitational deviation. During the Mars crossing, the unexplained thermal spike, and between them, a curious radio silence, a literal one. Deep space arrays monitoring the object's path reported temporary background damping in the 8 to 10 GHz range, as though a segment of the spectrum had been muted. The signal loss lasted only minutes, reappearing once 3I Atlas had moved beyond the line of sight. Engineers attributed it to interference or atmospheric noise. But when the same pattern repeated weeks later during another pass, some began to wonder if the object itself was interacting with radio frequencies in ways they didn't understand. To the public, none of this was visible. The object remained a faint point in the sky, indistinguishable from any other speck of light. But within the scientific networks tracking its motion, tension was building. The data didn't behave like a comet's, the path didn't behave like debris, and every time a new dataset arrived, the models became less certain. Theories multiplied. Some argued it was a fragment of an exoplanet's metallic core, ejected by a supernova and polished by eons of interstellar erosion into a symmetrical form. Others speculated it was a long-period comet that had somehow acquired a metallic shell, a natural coincidence of chemistry and luck. Yet each theory strained against the same wall, coincidence piled on coincidence. The right angle, the right timing, the right visibility, all converging on a moment when humanity could see it best. By late October, researchers from the International Center for Theoretical Astrophysics released a quiet but unsettling paper. Using orbital data from multiple agencies, they mapped 3I Atlas's trajectory backward through the solar system and found that its path intersected the orbital longitudes of Jupiter, Mars, Earth, and Venus in a near-linear sequence spaced at near-equal angular intervals. In simple terms, it wasn't just visiting planets, it was moving through their orbital positions like waypoints on a route. A statistically improbable sequence, the authors called it. But off-record, one of them used another phrase, survey pattern. NASA declined to endorse that interpretation. But the agency did announce plans for an emergency observational campaign, the largest coordinated optical effort since comet Shoemaker-Levy 9 struck Jupiter in 1994. The goal was simple. Capture everything when 3I Atlas reappeared. Track its spin, brightness, chemical spectrum, any hint of motion unaccounted for by gravity. The implication behind the planning was clear. They were expecting surprises. Still, the central question remained maddeningly simple. Why the planets? Why this sequence? Even if entirely natural, the pattern demanded explanation. Some speculated the object's path might represent a gravitational minimum energy corridor, shaped by the solar system's mass distribution. Others proposed the coincidence resulted from the same bias that colours our observations of meteors. We only notice the ones that cross our field of view, but those explanations strained under the sheer numerical improbability. Tens of millions of comets have passed unseen through the outer system, yet this one, of all possible orbits, happened to pass by the three worlds with active observers. By the time the sun swallowed it from view on October 29th, the tension had hardened into silence. No telescope could see beyond the blinding corona. For 47 days, humanity would be blind to its motion, its temperature, its emissions. During that time, any course change could occur unnoticed. It could fragment, vanish, or, if the more imaginative theories held, adjust its path. The world could only wait. Every previous encounter had felt like rehearsal, each planetary flyby a line in a script leading toward December. Jupiter's precision, Mars's flash, the approaching alignment with Earth, all part of a chain that seemed to converge on a single moment. Whether by nature or by design, 3I Atlas was moving toward something. The final approach would decide what kind of story this truly was, a coincidence of celestial mechanics, or choreography written in interstellar space. And as the sun began to eclipse the object from every instrument on Earth, even the most skeptical scientists found themselves glancing at the date, December 15th, wondering not if we would see it again, but what it would look like when it returned. On October 29th, 3I Atlas vanished. For months, telescopes around the world had been locked onto its faint metallic shimmer. Then, in a single day, it slipped into the blinding veil of the sun. No light curve, no reflection, no emission line could pierce the glare. For the next 6 weeks, every instrument, on Earth, in orbit and beyond, would be blind. The object would pass behind the solar disk, hidden within the one place in the solar system where no one could follow. This was not just an astronomical inconvenience, it was the most frustrating gap in modern observation, a total blackout precisely when the object was expected to undergo its most intense transformation. During this phase, known as perihelion, 3I Atlas would reach its closest approach to the Sun. Temperatures would climb, outgassing would peak, and if any structural change were to occur, it would happen now. But as fate, or perhaps something else, would have it, that critical event was taking place beyond every line of sight. The geometry is cruelly perfect. From Earth's perspective, the object passes directly behind the solar disk, lost in radiation that drowns every wavelength. The Sun's glare extends millions of kilometers, far beyond where 3I Atlas would travel. Even NASA's Solar and Heliospheric Observatory, designed to study the Sun's corona, cannot see through that region. Its cameras saturate, producing only blank white fields. The James Webb Telescope, which could have captured infrared spectra through the glare, is pointed deliberately away. It cannot risk damage from direct solar exposure. Every tool humanity possesses for remote observation is useless during this window. It's a moment astronomers both dread and crave. Because when it emerges again, on December the 15th, everything about it could be different. Perihelion is a crucible. The solar flux at that distance is nearly 5 times what Earth receives. Ordinary comets flare dramatically, shedding layers of ice and dust, brightening to visible magnitudes. But 3I Atlas is not ordinary. Its composition defies the rules of comet thermodynamics. Nickel, CO2, metallic compounds, materials that should not survive at such proximity. The expectation, even among the most cautious researchers, is that something must give. Either the object will fragment under stress, revealing its internal structure, or it will resist entirely, displaying an integrity no natural body has shown before. Both outcomes are historic. For weeks leading up to the blackout, observatories raced to collect final data before the object disappeared. The last successful spectrum came from the Very Large Telescope in Chile, recorded just hours before conjunction. The analysis showed a curious shift. The nickel emission lines were broadening, as if the gas velocity had increased. Thermal models suggested surface temperatures exceeding 1000 Kelvin, far hotter than any cometary surface recorded at that distance, and yet no signs of disintegration. Instead, the outgassing appeared to slow, not accelerate. The jets weakened, the coma shrank, the brightness dimmed. It was as though the object was shutting itself down in preparation for the solar crossing. That pattern unsettled the teams monitoring it. In theory, increased solar heating should trigger violent venting. In practice, 3I Atlas seemed to do the opposite. It quieted. Its activity decreased by almost 40% in the final 2 days before conjunction. Spectral intensity dropped. The reflective curve flattened. Even the nickel signature, its most distinctive trait, faded below detection thresholds. What was left was a cold, inert point of light moving steadily toward the Sun. Some scientists saw this as evidence of a metallic crust thick enough to insulate the volatile material beneath. Others speculated about surface vitrification, melting into a smooth, glass-like shell that sealed off active vents. But there was another, less comfortable interpretation, that the change was deliberate, a kind of thermal adaptation, as though the object had prepared for the Sun. The timing of its disappearance didn't help ease that suspicion. The exact date of solar conjunction, October 29th, had been predicted months earlier, but the approach vector leading into that window was unnervingly precise. The last frames from the solar orbiter show 3I Atlas entering the corona's edge at precisely the angle calculated to minimize exposure to the Sun's magnetic field. Even a fraction of a degree difference would have altered the heating pattern dramatically. Instead, the path followed what mission engineers described as textbook efficient. If one were designing a route to survive a close solar pass, this would be it. Inside the hidden zone, no one can confirm what happens, but from a mathematical standpoint, the period of invisibility lasts 47 days. During that time, its distance from the Sun will shrink to 0.46 astronomical units, then expand again as it slingshots outward. Assuming no fragmentation, it should emerge almost directly along the same trajectory. But there's a quiet understanding in the scientific community. If the path shifts even slightly, if its outbound vector deviates from projection, it will mean that forces other than gravity have acted on it. That possibility keeps analysts awake. A single change in inclination or velocity could rewrite the entire narrative, from natural curiosity to something engineered. And there's another angle few admit publicly. If 3I Atlas possesses any kind of self-regulation, whether mechanical or magnetic perihelion is the phase when it would most likely activate. In the absence of direct observation, agencies rely on modelling. The Parker Solar Probe, currently orbiting at 1/10 the distance of Mercury, has been tasked with measuring solar wind behaviour near the object's projected path. Already, the probe's magnetometers have detected subtle distortions, brief, localised turbulence not attributable to standard coronal mass flows. Correlation with 3I Atlas's predicted position is tentative but intriguing. Some researchers privately suspect the object may be interacting with the plasma environment in a way we don't understand, perhaps deflecting charged particles, perhaps emitting its own field. But until December, those remain conjectures, written carefully in technical language that hides their implications. For now, the story of 3I Atlas is paused in silence. The sun has swallowed it completely. Every telescope image shows the same thing: nothing. A blank centre where, just weeks ago, a glowing blue object drifted through space. The data streams have stopped. The only signals left are from predictive models and waiting instruments, poised to catch the first photon when it returns. And yet, even in absence, the object dominates discussion. Inside mission control rooms, researchers run simulations again and again, watching for possibilities. Could the nickel emissions resume after perihelion? Could the outgassing change composition? Could it brighten, or worse, go dark? No one knows. Each answer carries different consequences. If it fragments, it's natural. If it shifts orbit, it's not. Every major observatory has scheduled observation blocks beginning December 10th, 5 days before the expected reappearance. Spacecraft from multiple agencies, Webb, Hubble, Solar Orbiter, Parker, and even small CubeSat missions, are coordinated to capture the event. For the first time, the entire global astronomical network is acting as one synchronized eye. Whatever happens behind the sun, the moment it reappears, we'll see it. Until then, the world waits through a strange kind of darkness. The mystery of 3I Atlas has slipped into the one place in space where even the most advanced technology cannot reach. It is gone, hidden by the very star that gives us light. And that fact alone feels symbolic. An object that challenges our understanding, retreating into the heart of what we still don't fully comprehend. If this were merely chance, it would be poetic. If it's not, then the timing borders on theatre. Because of all the dates, all the distances, all the alignments in the solar system, 3I Atlas chose the only path that would take it behind the sun, unseen, for exactly the amount of time needed to reset every expectation. In December, when it returns, we'll know whether it comes back the same, or not at all. The silence that began on October 29th has stretched into weeks. The world's most advanced instruments, once locked on a single point in space, now face only glare. 3I Atlas is gone, swallowed by the sun's brilliance. But the countdown has already begun. In less than 2 months, on December 15th, it will return. And when it does, every telescope, radar and probe humanity can spare will be waiting. Astronomers call this the December window, the brief period when 3I Atlas will re-emerge from behind the sun and pass through a line of alignment that places Earth, the Sun, and the interstellar object on nearly the same plane. It's not just a date on a chart, it's an event years in the making, a moment when chance geometry and planetary motion combine to create one of the most perfect observational opportunities in modern science. It's also the day that could decide what 3I Atlas truly is. For months, researchers have treated this alignment as an astronomical gift. When an interstellar body moves behind the sun, the radiation it absorbs and emits changes dramatically. As it re-emerges, its thermal and spectral behaviour can reveal internal composition, density and structure, clues no remote instrument can otherwise reach. But this time, the attention isn't purely scientific. The December alignment has taken on an air of anticipation, almost tension, because it represents something bigger than data. It's the test. The alignment is not accidental. At least that's how it feels when you look at the geometry. Earth orbits at an angle, that only rarely places it along the same solar line as a fast-moving interstellar body. In this case, the alignment is near perfect. Earth, Sun, and 3i Atlas forming a single, continuous axis in space. The error margin is barely a fraction of a degree. Such precision is statistically negligible, the kind of coincidence that mathematicians describe with unease. The same unease has begun spreading among those tasked with explaining it. For the general public, December 15th has become a kind of mythic marker. News outlets, podcasts, and forums refer to it with growing drama. The day we'll know, the day the data comes back, the day the sky might change. Official agencies downplay that tone, of course. NASA's language remains measured. Coordinated observations to resume upon post-conjunction reappearance. ESA's statement is even drier. Nominal tracking scheduled pending visibility conditions. But within scientific circles, nobody hides the truth. They are preparing for the most critical observation campaign of the decade. The reason is simple. What happens after perihelion, how 3i Atlas behaves when it re-enters view, will either confirm a natural origin or open questions no one is prepared to face. The upcoming window offers humanity a chance to catch it in transition, to see whether the sun's proximity altered it, fractured it, or perhaps awakened something dormant inside it. In late November, the first indirect indicators will arrive. Solar probes will measure plasma density near the predicted re-emergence zone, scanning for disturbances that might mark its path. Radio telescopes will listen for narrowband emissions, hunting for any modulated frequencies embedded within the noise. Then, as the date approaches, optical systems will engage. At first, faint infrared readings, then perhaps the first flicker of light. If all goes as planned, by mid-December, we will see it again, either intact or not. The stakes are higher than they seem. 3i Atlas is no longer just a comet to astronomers. It's become a mirror reflecting the limits of our understanding. Each anomaly it presents, its metallic composition, its improbable orbit, its synchronized flybys, has chipped away at the comfortable boundaries between what's explainable and what's not. Now, this final act, the December return, feels like a verdict. Some researchers expect it to brighten dramatically, flaring as residual volatiles sublimate under renewed sunlight. If that happens, they'll call it proof of natural behavior, a comet revived after dormancy. Others think it will dim even further, perhaps having sealed itself during its hidden phase. A third group, small but vocal, believes we may see something stranger, a change in motion, an alteration in trajectory or rotation that cannot be explained by physics alone. Among them is a consortium of independent astrophysicists operating under the name Atlas Watch. They've built a distributed network of amateur and professional telescopes across 5 continents, all synchronized by atomic time signals. On December 15th, every one of those instruments will track the same coordinates, recording every photon. The idea is redundancy. If anything unexpected happens, an acceleration, a spectral shift, a sudden flare, no single source can dismiss it as noise. The data will be global, simultaneous, and impossible to ignore. The James Webb Telescope will play a central role. Its instruments are sensitive enough to detect minor changes in elemental composition during the reappearance. JWST's mid-infrared spectrograph is tuned specifically to monitor the nickel and CO2 lines that first exposed 3i Atlas's chemical oddities. If the ratios shift, if new compounds emerge or old ones vanish, scientists will have their answer about the nature of its surface. Some even hope the readings might reveal isotopic anomalies, subtle fingerprints that could determine whether the object was formed in a star system like ours or somewhere entirely different. But there's another layer to the anticipation, one that most press briefings avoid. If 3i Atlas emits any kind of modulated light, any pattern repeating with mathematical regularity, it will trigger the largest data escalation in the history of astronomy. The SETI network, the Deep Space Network, and radio observatories around the world have quietly added the object's coordinates to their automated signal detection algorithms. No one wants to use the word communication, but privately several engineers admit that if any narrowband signal is detected near the re-emergence, they won't dismiss it as interference. Not this time. There's a quiet irony in how human behaviour mirrors the object's mystery. The same agencies that once competed for telescope time are now cooperating with almost military precision. The entire global astronomical infrastructure has been synchronized to one moment, one line in space, one question. It's an alignment not just of planets, but of human curiosity. In control rooms and observatories, the atmosphere is tense. Some treat December 15th like a scientific holiday. Others treat it like a test of nerve. Engineers calibrate instruments down to the last decimal, aware that they may only get a single chance before the object drifts too far. The last time Earth and 3i Atlas will share this alignment is now. When it leaves the inner solar system, it will be gone forever. Every new day of waiting amplifies the speculation. If the object brightens, it will be hailed as confirmation of a natural cometary physics. If it darkens, questions will spread. If its path changes, even slightly, everything will unravel. And if it does something no one expects, pause, pulse, emit, or vanish, then the mystery of 3i Atlas will shift from scientific anomaly to existential enigma. For now, silence. The sun holds it hostage, and the data feeds are empty. Researchers run simulations, refining orbital models that may or may not hold when the real object returns. News anchors fill the void with speculation. Online forums build countdowns. And in private meetings, policy advisors draft contingency statements, just in case the unthinkable becomes visible. Because on December 15th, when 3i Atlas reappears, the story stops being theoretical. It becomes observable, measurable, undeniable. Whatever happens, brightening, fading, silence, or signal, it will mark a line between what we understood before and what we'll never see the same way again. Until then, the world waits for a single re-emergence, a flicker of blue light near the sun's edge that could either confirm everything we know about the universe, or show us something we never imagined it contained. When the first whispers of a nickel signal surfaced in early data reports, they were dismissed as overinterpretation, artifact, calibration error, coincidence. But over time, as new observations repeated the same spectral fingerprints, that quiet anomaly hardened into one of the central mysteries of 3i Atlas. Because what scientists were seeing didn't belong in any known category of natural emission, it looked structured, it looked timed, and that, more than anything, was what made it unsettling. The story began with spectroscopy, again. Nickel had been the defining chemical signature of 3i Atlas since its discovery. It wasn't just that nickel vapor was present, it dominated, drowning out the typical cometary gases like water, cyanide, or dustborne organics. Even before conjunction, instruments on Earth and in orbit had detected persistent nickel emission lines, particularly near 341 and 347 nanometers. Those lines were clear, crisp, and, most confusingly, steady. But in the weeks leading up to October 29th, a subtle modulation appeared within them. It was so faint that most instruments missed it entirely. Only after multiple datasets were cross-correlated did the pattern emerge. The intensity of the nickel line wasn't constant. It fluctuated. The oscillation was periodic, repeating every 73 minutes. Too short for diurnal heating, too long for thermal flicker. When the same modulation was later detected across two independent telescopes, thousands of kilometers apart, instrumental noise could be ruled out. Something in the light itself was pulsing. And that pulse wasn't random. It followed a clean harmonic rhythm, almost like a carrier wave in radio transmission. At first, it was assumed to be rotational, a bright patch on the surface spinning in and out of view, altering the amount of reflected sunlight. But the problem was that 3i Atlas's rotation period, measured from its light curve, was nearly 11 hours. There was no simple way to reconcile a 73-minute modulation with an 11-hour spin unless there were multiple sources, multiple vents, firing in synchronized sequence. The odds of that synchronization occurring naturally were infinitesimal. When the data reached the spectroscopy team at the European Southern Observatory, they ran a Fourier analysis of the signal. The results stunned them. The modulation wasn't a perfect sine wave. It had overtones, secondary frequencies stacked at exact integer multiples of the base frequency. Harmonics like that do appear in nature, but not often, and rarely with such mathematical precision. The most unsettling part was that the amplitude ratios between those harmonics matched a geometric progression. In simpler terms, the pattern looked engineered. Still, the team stopped short of using that word. In their internal memo, they described it as a non-random periodic emission potentially indicative of structured venting or compositional oscillation. A sentence so carefully phrased, it could mean almost anything or nothing at all. NASA's Goddard spectroscopy group took a different approach. They suggested that the modulation could arise from nickel tetracarbonyl gas resonating under alternating magnetic exposure. If 3I Atlas carried a remnant magnetic field, perhaps from a metallic core, solar wind interaction might drive cyclical excitation of the compound, producing rhythmic spectral shifts. It was an elegant theory. It explained the timing, the harmonics, even the coherence, but it also implied that the object was actively maintaining a magnetic structure stable enough to produce resonance at consistent intervals. No known comet or asteroid does that. As October turned to November and the object vanished behind the Sun, data collection halted. But radio telescopes didn't. They began scanning the region where 3I Atlas would eventually re-emerge, searching for correlated frequency noise that might indicate continuing modulation. Most found nothing. Yet one array, the Allen Telescope Array in California, reported something peculiar, a faint narrowband fluctuation near 8.1 GHz, rising and falling at exactly the same 73-minute interval as the earlier optical modulation. It was weak, just above the noise floor, and lasted for less than 6 hours before fading completely. When cross-checked with other arrays, no match was found. The detection was never confirmed. Officially, it remains an anomaly, probably interference, possibly coincidence. Unofficially, it's known as the nickel signal. The possibility that a single element, nickel, could be communicating anything sounds absurd. Spectroscopy doesn't carry language, it carries chemistry. But what makes the situation unique is that the emission pattern appears modulated, not simply periodic. And modulation, in scientific language, implies encoding, even if that encoding arises from physics alone, like pulsars, which emit steady signals as they spin. The question remains, what mechanism could produce such clean order in a comet's chaotic environment? At the University of Cambridge, a small research collective led by astrophysicist Rena Malik ran simulations to test whether sublimation cycles could mimic such patterns. They modelled hypothetical vents releasing gas under alternating illumination from rotation. The result was irregular, unstable, noisy. The natural processes refused to settle into harmony. Only when they introduced an artificial constraint, a control function limiting emission intensity, did the models reproduce the observed signal. That control function could represent magnetic feedback, crustal conductivity, or something else entirely. But it was not random. Around the same time, ESA's solar orbiter detected small-scale fluctuations in solar wind density, trailing the projected position of 3I Atlas. They were rhythmic as well, tiny compressions in plasma flow, like the ripples behind a passing vessel. Some researchers speculated that the object might be generating its own magnetic wake, either passively through induction or actively through emission. The data were inconclusive, but the coincidence in frequency, once again matching the 73-minute period, didn't go unnoticed. Behind closed doors, the topic became radioactive. No one wanted to be the first to suggest an unnatural explanation, but no one could dismiss the patterns either. The debate split the community. Some argued for unknown physics, electromagnetic self-regulation within metallic interstellar debris. Others proposed that we were seeing the relic behavior of something technological, long dormant, still emitting structured signals as its systems decayed. In the latter view, 3I Atlas was not a probe, but a corpse, a machine still murmuring its final code into the void. There is, however, a quieter, more grounded explanation that continues to hold weight. Nickel tetracarbonyl under high solar heating can spontaneously dissociate and recombine in cyclic reactions. Each cycle releases energy, and the rate of those cycles could, in theory, stabilize into resonance. In that case, the 73-minute pulse would be nothing more than chemistry playing out at astronomical scale. Yet even that explanation leads to wonder, a natural molecule behaving like a timekeeper, ticking rhythmically in the dark as if the cosmos itself were keeping score. As December approaches, instruments have been recalibrated to watch for the signal again. If it returns after perihelion, stronger, weaker, or changed, it will tell scientists whether the emission was internal or environmental. If it remains perfectly timed despite the object's thermal stress, then something deeper is at work. The world won't have to wait long. As 3I Atlas emerges from behind the Sun, its first light will be captured by ultraviolet spectrometers tuned precisely to those nickel lines. Any modulation, any variance will appear instantly. If the rhythm persists, the discovery will make history, not because it proves anything about intelligence, but because it forces science to expand its definition of order. There's something poetic about it too. A pulse of nickel light travelling through space, repeating like a heartbeat, indifferent to our interpretations. Whether it's the breath of chemistry or the residue of something made, it moves with the same calm regularity, a frequency steady and ancient, marking time as the object sails past our star. Soon the silence will break, the data will flow again, and somewhere, hidden in that stream of numbers, the rhythm may still be beating. Quiet, persistent, mathematical. A signal written not in words, but in light. The absence of data has a sound of its own. It's the quiet hum inside observatories at midnight, the stillness of control rooms where screens stay blank, and the whisper of static from antennas pointed at the void. Since 3I Atlas slipped behind the Sun, that silence has become louder than any discovery. It's a silence filled with expectation, uncertainty, and something close to dread. For nearly a month now, the world's largest instruments have been staring at the coordinates where 3I Atlas should eventually reappear. They gather nothing, no spectra, no infrared echo, no trace of light beyond the solar glare. In astronomy, absence is data too, but this kind of absence feels different. It's not simply that the object is hidden, it's that the institutions watching it have stopped talking. Normally, when a discovery captures public interest, space agencies flood the internet with updates, press releases, preliminary graphs, outreach videos. With 3I Atlas, communication has slowed to a crawl. The official narrative remains fixed, no anomalous activity detected. Data collection paused until post-conjunction visibility, phrases so generic they sound automated. But inside research networks, leaked emails tell another story. Internal channels at NASA, ESA, and several national observatories have gone unusually quiet. Shared databases, once updated daily with raw telemetry, now show long gaps. It's as if the flow of information itself has entered conjunction. The first sign came in early November, when the European Southern Observatory removed its preprint analysis on the nickel emissions from its public archive. The file simply vanished, replaced by a placeholder citing Data Integrity Review. A few days later, 2 independent research groups, one in Japan, one in Canada, reported that their telescope time allocations for December had been restructured under a coordinated directive. Neither knew why. Then, a terse memo appeared in a professional mailing list used by planetary scientists. All optical tracking of Object 3I/2025 R2 Atlas will be consolidated under Joint Observation Campaign December 2025. Please defer individual proposals. To most people that sounded harmless. But to astronomers it meant something very specific. Someone had centralized control. No more scattered studies, no more freelance observers pointing cameras into the dark. The object had become restricted, officially coordinated, but effectively quarantined. At the same time, communication from the Deep Space Network began to show odd scheduling gaps. Segments of its public logs, normally routine, were redacted or missing entirely. Amateur radio astronomers noticed that several antennas, including Goldstone's DSS-14, were pointed toward the inner solar system far longer than normal, despite no declared missions in that region. On social media, speculation ran wild. Some claimed the agencies were tracking a deviation in trajectory. Others thought the silence meant something catastrophic: fragmentation, impact, disappearance. The truth was simpler and more complicated. No one outside the inner circle knew anything. Inside that circle, information moved quietly through encrypted channels. A few scientists, speaking anonymously to colleagues, described a growing sense of frustration. They were not being given new data. Observations from space-based instruments were being withheld pending review. Several compared the situation to the months following Oumuamua's 2017 flyby, when agencies moved cautiously, terrified of misinterpretation. But this time the coordination was tighter, the oversight more deliberate. Someone had decided that the story of 3I Atlas needed careful handling. The reason they suspected was the signal, the 73-minute modulation in the nickel lines. The so-called nickel pulse had circulated through the research community in early October, sparking quiet fascination. Then suddenly, every reference to it disappeared from internal archives. Even mentions on private Slack groups vanished as administrators scrubbed files. It was as if the anomaly itself had been erased. Whether the motive was caution or suppression remains uncertain. One explanation is bureaucratic. Extraordinary claims require extraordinary scrutiny, and releasing ambiguous data risks embarrassment. Another, less charitable view is that the agencies feared public hysteria. The idea of a rhythmic signal from an interstellar object was too close to a narrative they couldn't control. Better to delay, verify and reframe later. Meanwhile, the independent astronomers, those outside government or university payrolls, continued to watch. They had smaller telescopes, less sensitivity, and no access to high-end instruments. But they still had the sky. Some of them started sharing nightly measurements of the sun's coronal outflow, hoping to detect indirect traces of 3I Atlas's passage. None succeeded. The object was buried too deep in light, and yet, on November 23rd, one observer in southern Chile recorded something odd. Using a narrowband filter to monitor coronal plasma, he captured a faint, localized dip in solar wind density lasting roughly 10 minutes. It was small, barely above the noise threshold, but the timing matched the predicted path of 3I Atlas almost perfectly. When he posted the data online, it spread across amateur astronomy forums overnight. Within hours, the post was flagged and removed. He later said he received a polite but firm email from an unnamed institutional contact advising him not to draw premature conclusions. It was a minor incident, easily forgotten, but for those following the object closely, it added to the feeling that something was happening out of sight, not just beyond the sun but behind institutional walls. By early December, the absence of information had turned from curiosity to unease. A new pattern emerged. Scientists who had spoken openly about the object were suddenly silent. Interviews cancelled, comments retracted, scheduled conference talks postponed due to data embargo. When a journalist asked a NASA official about the embargo, the response was a flat denial. No data has been restricted. But the pattern was unmistakable. Something about the observations, or perhaps their interpretation, had triggered the kind of quiet that usually follows classified findings. The public, of course, filled the silence with its own noise. Online threads exploded with theories. Alien probes, secret weapons, experimental spacecraft. The more rational voices tried to cool the conversation, reminding everyone that correlation isn't proof, that silence often means nothing, but silence also invites imagination, and imagination rarely stays calm. Inside observatories, though, the mood was different, less dramatic, more strained. Researchers weren't imagining extraterrestrial intent. They were struggling with the bureaucratic reality of studying something extraordinary under institutional supervision. Many described the same feeling. The science had been taken out of their hands. Decisions about what could be shared, when, and how were being made by committees they had never heard of. One astrophysicist compared it to trying to look through a locked telescope. It's not that agencies are hiding aliens, it's that they're terrified of being wrong. A rhythmic pattern could be physics, chemistry, or artifact, but once the idea of communication enters the public sphere, it cannot be contained. Every data point becomes symbolic, every pixel evidence of intent. That's why the silence persists. The less they say, the less they can misstep. Still, silence has consequences. The longer it stretches, the more it shapes perception. By December 10th, the start of the reappearance window, there are no official briefings, no live observation streams, nothing beyond vague statements about ongoing analysis. Even the amateur networks have begun to splinter, unsure whether to trust their own eyes when the object finally reappears. What's most remarkable is how the silence has become part of the story itself. 3I Atlas is invisible, not just because it's behind the sun, but because it sits at the intersection of uncertainty and control, too anomalous to dismiss, too dangerous to interpret freely. Every scientist watching knows what this means. When the data finally resumes, it will not come as a raw feed. It will arrive as a narrative, filtered and phrased, polished for consumption. And perhaps that's inevitable. Science, after all, is a human institution, and institutions are built on caution. But in this case, the caution feels heavy, almost offensive. Something about 3i Atlas seems to have unsettled not just physics, but the structure of how we study it. In a few days, that may change. Once it emerges from conjunction, the data floodgates will open, if they open at all. Either the silence will break with clarity, or it will deepen, suggesting that what was found behind the sun isn't ready to be shared. For now, all we have is the hum of machines waiting to see a light that isn't there, and the quiet understanding that silence too can mean something, especially when it lasts this long. In science, caution is a virtue, but when the unknown begins to stare back, caution can turn into paralysis. That's where the study of 3i Atlas now stands, balanced uneasily between discovery and denial, between data and disbelief. Every agency, every research group, every voice that once spoke freely about it now measures each word as if it could tip something fragile. The phrase asymmetric caution began appearing quietly in the internal correspondence around mid-November. It was meant as a technical term describing a bias that grows when the cost of overreacting is perceived to be greater than the cost of being wrong. It's a mindset that infects institutions under uncertainty. When something potentially extraordinary emerges, something that could change the narrative, scientists hesitate to acknowledge it, fearing ridicule, funding cuts, or public misunderstanding. Better to downplay than exaggerate. Better to wait than to wonder aloud. With 3i Atlas, that instinct has become doctrine. The same researchers who once debated openly on live forums now speak in code or not at all. Public papers use phrases like statistical irregularity instead of anomaly. Leaked drafts reveal language stripped of curiosity. Further analysis needed. Insufficient evidence to support deviation. The excitement that once surrounded the object has been sterilized into professional restraint, and yet everyone knows why the restraint exists. It isn't just scientific humility, it's fear. The fear of being the next person to say the wrong thing. The fear of seeing a pattern where there isn't one. Or worse, the fear of seeing something real that no one else is ready to face. Inside agencies, meetings about 3i Atlas are conducted with what one participant described as surgical calm. Engineers present raw telemetry without adjectives. Analysts use passive voice. A modulation was observed. A fluctuation was noted. Directors avoid speculation altogether. The atmosphere resembles a courtroom more than a research briefing. Facts are admitted carefully. Implications deferred indefinitely. It wasn't always like this. When Oumuamua was discovered in 2017, speculation flourished. Scientists argued openly in journals, on television, in podcasts. The public saw science alive, uncertain but unafraid. With 3i Atlas, the stakes feel heavier. There's more data, more coordination, and more to lose if interpretation slips beyond control. That's why, this time, the tone has changed from wonder to management. In mid-November, a classified interagency panel reportedly convened in Washington, an unusual move for an astronomical object. The participants included representatives from NASA, the National Science Foundation, and several defense departments. Their purpose was not to investigate alien life, as rumors suggested, but to establish communication protocols. If the December re-emergence produced anything that looked like a signal, any measurable modulation or frequency pattern, they wanted a unified response. No leaks, no contradictory statements, no panic. This was the essence of asymmetric caution. Prepare for the impossible, but behave as if it's impossible to discuss. It's a kind of bureaucratic Schrödinger's box, containing both the acknowledgement of potential contact and the refusal to name it. For scientists, this restraint is suffocating. Many of them joined astronomy for its openness, the joy of shared discovery, the global exchange of information. Now they find themselves navigating a landscape where curiosity feels like risk. Some have begun leaving encrypted notes in their data logs, small human gestures to remind themselves that wonder still exists behind the rules. One researcher described the new atmosphere as professional skepticism weaponized. Every suggestion that steps beyond the line of accepted explanation is quietly sidelined. Funding proposals referencing technological hypotheses are returned without comment. Conference papers that mention coordinated emission patterns are flagged for revision. The system isn't censoring discoveries, it's sterilizing them before they can take root. But asymmetric caution isn't just institutional, it's personal. Scientists are trained to question everything, including themselves. They understand how easily bias can distort interpretation. When faced with an anomaly like 3i Atlas, that self-doubt becomes a defense mechanism. If something looks engineered, they remind themselves that nature often mimics design. If data looks too clean, they assume instrument error. It's not cowardice, it's discipline. Yet in this case, the discipline has hardened into disbelief. Outside the labs, the public senses the tension. Every day without news feels like a choice, not a delay. The absence of information feeds speculation, and speculation feeds fear. But from the inside, the silence feels less like secrecy and more like survival. In a world that demands certainty, admitting confusion has become dangerous. There's an irony here. The very institutions designed to explore the unknown are the least able to speak freely when they find it. Their reputations depend on the illusion of control, the idea that every discovery fits into an existing framework. But 3i Atlas refuses to fit. It drifts outside the boundaries of known physics and known comfort, and that is precisely why the system cannot afford to engage with it honestly. In December, when the object reappears, asymmetric caution will dictate how the story is told. The first press release will be bland. The first scientific summary will use conditional verbs, may, might, suggests. No one will say the word signal. No one will mention the possibility of design. They will talk instead about unusual emission stability, non-standard morphology, and deviation from expected thermal response. In other words, they will describe the extraordinary without acknowledging it. And yet, behind those careful sentences, the real work will continue. Late at night, in data labs and remote observatories, the unfiltered numbers will flow. Some will whisper about harmonic repetition, about spectral coherence, about structure in the noise. But their voices will remain private, recorded in notebooks, emails never sent, conversations that end with, "Let's not put this in writing." Asymmetric caution also means asymmetric knowledge. The more delicate the information, the fewer people see it. A handful of analysts will have full access to raw data. Everyone else will receive summaries. That hierarchy creates a vacuum, one where rumour thrives. And in that vacuum, 3i Atlas stops being a comet or an object or even a scientific phenomenon. It becomes a reflection of our own uncertainty, our collective inability to decide what kind of truth we're ready to accept. There's a quiet tragedy in that. For centuries, astronomy has been humanity's purest pursuit of knowledge, a field defined by patience and wonder. But as our instruments grow sharper and our discoveries stranger, we've begun building walls around what we can admit. 3i Atlas is testing those walls. Every data point presses against them. The scientists who know this best are the ones still looking, still running simulations, still tracking the math even when they're told not to speculate. They understand that history doesn't always announce itself. Sometimes it hides behind bureaucratic caution, waiting for someone brave enough to describe what everyone else is afraid to name. Whether 3i Atlas is a natural wonder or something else entirely, it has already done something remarkable. It has forced us to confront the limits of our own confidence. It has reminded us that science, for all its precision, is still human, vulnerable to politics, fear, and silence. And as December 15th approaches, that silence becomes almost unbearable. Because everyone watching knows what's coming. The instruments are ready, the world is waiting, and the only thing louder than the noise of data will be the hesitation to say what it means. When 3i Atlas emerges from behind the sun, a symmetric caution will meet its breaking point. Either the data will restore certainty, or it will destroy it. And for the first time in modern history, the question may not be what we find, but whether we're allowed to believe it. The closer the date approaches, the more the scientific world divides. The mystery of 3i Atlas has evolved into two incompatible explanations, one that preserves the laws of physics and another that quietly threatens them. Both claim the same data. Both insist on reason. But behind the language of mathematics and caution, a philosophical war is unfolding. At its heart, the debate is not about what 3i Atlas is, but about what science is willing to allow. Every observation, from its nickel-rich composition to its improbable orbit, forces the field to choose between stretching existing theories or accepting the possibility of intent. And that's a line most researchers still refuse to cross. The first model, the naturalist one, treats 3i Atlas as a cosmic coincidence magnified by technology. According to this view, every anomaly can, in principle, be explained by physics. The nickel-only emissions, the strange orbital alignments, the harmonic pulses, none of it requires intelligence, only complexity. Nature, they argue, can generate order that looks like design. Dr. Marina Koch, a leading astrophysicist at the Max Planck Institute, is one of the loudest voices in this camp. She describes 3i Atlas as a metallic cometary remnant, a fragment from a system where heavy elements condense differently than ours. Her models suggest that under certain conditions, extreme carbon saturation, vacuum metal crystallization, and low gravity, a body could form with nickel-dominant chemistry. In that case, the peculiar composition isn't manufactured, it's inherited. She goes further. The rhythmic signals, she says, might be thermochemical oscillations, self-regulating heat cycles within the crust. The apparent precision of the 73-minute modulation could simply be resonance between outgassing vents and rotational harmonics. If you watch a geyser long enough, she told an interviewer, it looks like a clock. But it's still water, not intention. It's an elegant argument, one that preserves both science and sanity. Her papers, cautiously worded, emphasize probability over mystery. She calls 3i Atlas a valuable outlier, nothing more. Her critics call that understatement a form of denial. On the opposite end stands a smaller but growing camp, the technogenic theorists. They don't claim 3i Atlas is a spacecraft. They don't even claim it's active. They simply point out that too many variables align too cleanly. The chemical ratios are constant across months. The orbital trajectory follows near-perfect planetary synchrony. The modulation is harmonic, not chaotic. Statistically, the combination of all those features occurring together should be almost impossible. Their argument is built on accumulation. Each anomaly, taken alone, is explainable. Together they form a pattern that starts to look deliberate. As one researcher put it, if you flip a coin 100 times and get heads every time, you don't call it coincidence. You check the coin. Among this group, the most cited work comes from a multinational team at the University of A Coruña in Spain, the same team that earlier proposed a natural interstellar origin. But in their revised model, they introduced a curious phrase, engineered stability. They argued that the light curve of 3i Atlas displays mechanical coherence, a smoothness inconsistent with sublimation-driven motion. In their simulations, a hollow or layered internal structure could reproduce that coherence, especially if it contained internal voids or reinforcement patterns. Such a body, they noted, would survive solar heating far better than a uniform rock. They never said it was artificial, they only said it behaved as if it were designed to endure. This linguistic caution, these two words as if, have become the dividing line of the debate. For the naturalists, it's irresponsible suggestion. For the technogenic theorists, it's the only way to describe what the data shows without crossing into speculation that could end careers. In late November, an internal symposium was held between both groups. It wasn't publicized. Officially, it was a cross-institutional data harmonization meeting. Unofficially, it was an argument that lasted 12 hours. Participants described the tone as civil but tense. Equations were projected onto walls. Models of rotation, thermal stress, and gas venting were compared line by line. At one point, a researcher from NASA's Jet Propulsion Laboratory presented a slide showing trajectory probabilities for naturally occurring interstellar bodies with similar orbits. The number glowed on the screen, 0.00000012, a 1 in 8 million likelihood. Silence followed. Someone finally broke it by saying, "So we're 8 million to 1 against nature?" The presenter didn't answer. After the meeting, no consensus emerged. Instead, the two camps retreated further into their positions. The naturalists tightened their models, focusing on statistical justification. The technogenic side turned introspective, shifting from proof to philosophy. What does it mean, they asked, if something behaves intelligently but shows no sign of intent? At what point does pattern become message? As the debate spread, journals began refusing papers that mentioned 3i Atlas by name, citing speculative associations. The controversy had become too politically charged. One editor privately admitted, "We're not rejecting their math. We're rejecting the implications. The schism isn't just academic, it's generational." Younger scientists, less burdened by institutional fear, lean toward open curiosity. Many grew up in an era of exoplanet catalogues and deep space imagery, where the extraordinary became routine. To them, asking if something might be technological isn't heresy, it's hypothesis. Older researchers, however, remember careers ruined by overreach. They've seen what happens when imagination outpaces evidence. They call for discipline, for patience, for silence, until the data speaks. But the data is speaking. It's just speaking in riddles. Every new analysis seems to confirm both sides at once. Thermal models show natural behaviour, compositional ratios show engineered precision. The object's motion is purely gravitational, yet its stability defies known dynamics. It's Schrödinger's comet, both mechanical and organic, both chaos and control. And while scientists argue, policymakers prepare. Within international agencies, quiet contingency documents circulate. They don't mention extraterrestrial life, only non-naturally correlated phenomena. The wording is bureaucratic camouflage, but the intent is clear. If something unambiguously structured emerges from the December observations, if the nickel signal repeats or the object changes course, then protocols must exist before the public hears about it. For now, the committees agree on one thing. The truth will depend on what happens after December 15th. Until then, both models remain alive, like competing religions, each with its own faith in how the universe behaves. There's a strange symmetry in that. For centuries, science was the art of replacing belief with measurement, but 3i Atlas has blurred the line. The numbers themselves have become matters of belief. Whether it's nature or design no longer depends solely on data. It depends on how much coincidence one is willing to accept. In the end, perhaps both sides are right in ways they can't yet reconcile. The universe could indeed build order that mimics intelligence, and intelligence, if ancient enough, could design systems that look like nature. Between those two possibilities lies a narrow band of ambiguity, where 3i Atlas drifts now, half machine, half mineral, half metaphor. As the world waits for its re-emergence, the debate continues in whispers, in conference hallways, in encrypted chats between researchers who no longer trust the institutions that employ them. The models multiply, the arguments repeat. And beneath it all lies a single, shared truth. No one is certain anymore what natural even means, because if nature can imitate intention this perfectly, then perhaps intention was never separate from nature to begin with. Perhaps the cosmos has always been both builder and machine, and 3i Atlas, whether a rock or a relic, is simply showing us a reflection of that unity, gliding in silence, unbothered by our need to decide what it is. For all the numbers, all the spectra, all the orbital equations, the truth is this. No one knows what 3i Atlas looks like. Every image we've seen is a blur, every light curve an interpretation. Behind those graphs lies an absence so vast it feels deliberate. The object has revealed everything except its own form. We know its rotation period, its reflective index, its albedo fluctuations. We've measured its chemical emissions, its mass estimates, its trajectory to the decimal. And yet, the question of its structure, what it's made of, how it's arranged, what holds it together, remains the most stubborn mystery of all. Normally, shape is one of the first things astronomers can infer. The way an object brightens and dims as it spins tells us how uneven it is. Peaks and troughs in its light curve trace contours across space. That's how we learned that Oumuamua was elongated like a shard and that Borisov was rounder, more traditional. But with 3i Atlas, the light behaves differently. Its brightness doesn't fluctuate randomly, as it should if light were bouncing off irregular surfaces. Instead, the curve is unnervingly smooth, too smooth. It suggests symmetry or something close to it. Yet radar reflections, faint and distorted, hint at asymmetry. The data contradict each other in quiet ways. To one team, it appears oblong. To another, crescent-shaped. To a third, almost hollow. Every analysis agrees on one fact. Whatever the shape is, it's not simple. Early estimates suggested a body roughly 60 kilometers in length, perhaps 20 across. But that was before thermal mapping showed that heat wasn't distributed evenly. Some regions cool rapidly, others hold temperature far longer than expected. It's as if the object is composed of multiple materials, metal, stone, maybe even glass-like compounds, layered in ways nature rarely produces. The infrared data collected before conjunction hinted at something even stranger. The hottest zones weren't on the sunlit side, but on the shadowed edge, the side facing away from solar radiation. It's an inversion that defies normal thermodynamics. A few scientists suggested that buried volatiles could be venting from internal cavities, releasing heat from within. Others proposed that the material itself conducts energy in reverse gradients, but neither model fully explains the consistency of the pattern. When the data were shared privately among institutions, one interpretation quietly gained traction: internal structuring. Not merely a fractured core, but an organised interior, chambers, layers, or voids following a pattern. The theory was speculative, impossible to prove, yet oddly persuasive. If the object were hollow, or partially hollow, it would explain its stability, its smooth rotation, even its resilience against thermal stress. A porous lattice could absorb expansion without cracking. A few analysts went further. They modelled the possibility of a shell, a dense metallic crust enclosing a lighter interior. The math worked almost too well. The resulting density matched observations precisely. The rotation rate, the mass, the light curve, all fit within error margins tighter than chance should allow. One physicist called it a coincidence so perfect it's suspicious. NASA's public-facing response to such speculation was swift. No evidence supports artificial structuring, the statement read. Variations in thermal distribution are consistent with natural compositional heterogeneity. The sentence was carefully written, true, technically, but it skirted what many suspected, that heterogeneity alone couldn't explain how organised the anomalies were. Inside conference calls, the tone was more candid. "We've never seen a body behave like this," one researcher admitted during a closed ESA briefing. "If it's fractured, it's too symmetrical. If it's solid, it's too adaptive." Someone else added half-jokingly, "Maybe it's both." The transcript ends there, replaced by minutes stripped of adjectives. Every attempt to visualize 3i Atlas ends up describing contradiction. To some, it's a torus, a ringed structure with a central cavity that traps and redirects heat. To others, it's a long spindle, tumbling end over end like a slow baton. Some models even suggest it could be flattened, a broad crescent with a thin curvature, an impossible shape for a natural comet, but one that fits the observed scattering of light. The truth may lie somewhere between, irregular, layered, but purposeful in geometry. There's a deeper question here, one that science usually avoids asking: can shape itself carry information? If 3i Atlas were built, even by accident of geology, in a way that optimizes balance, rotation and endurance, then form becomes function. And if that form survives the heat of the sun, it becomes message, geometry enduring through time. The internal structure remains invisible to us because the tools to probe it simply don't exist. Radar can't reach an object that far. Seismography requires contact. Gravitational mapping depends on mass interaction. All we have is reflected light. Photons scattered off surfaces we'll never touch. Those photons are our only witnesses, and they speak in riddles. In one dataset captured weeks before conjunction, astronomers noticed something peculiar: micro-variations in polarization. The reflected light wasn't just changing in intensity, it was twisting, rotating in a pattern that repeated every few hours. Polarization changes like that can indicate crystalline structures or layered composites. But the pattern was unusually clean, too coherent for chaotic mineral grains. It looked, one analyst said, like something built with edges. Even so, no one dares publish that sentence in a paper. Words like edges and structure carry weight they can't retract. The fear isn't that it's wrong, it's that it's right. The debate about internal architecture divides scientists in quieter ways than the orbital or chemical controversies. It's not a war of papers or conferences, it's a war of glances, of unspoken agreement not to speak. In private, most admit the evidence points toward complexity. In public, they retreat to the comfort of uncertainty. We don't know is safe. We might know is dangerous. As the date of re-emergence nears, a few daring groups have begun preparing for direct imaging attempts. The Very Large Telescope in Chile has scheduled adaptive optics time to capture the first post-conjunction frame. If the object brightens enough, high-resolution composites may finally reveal surface texture, ridges, shadows, perhaps even reflective facets. But no one knows if it will cooperate. 3i Atlas may remain smooth and featureless, denying us one last truth. And yet, there's something poetic about that possibility. Perhaps the reason it looks featureless is because it was meant to. A surface too perfect to hold meaning, hiding whatever it carries inside. In that sense, it mirrors the institution studying it. Calm, polished, withholding. Behind all the models, shell, lattice, hollow, lies one shared admission. This object is not behaving like any natural aggregate we've ever seen. Its endurance, symmetry, and compositional consistency hint at architecture. Whether that architecture arose by accident or intention may never be known, but structure implies purpose, even if that purpose is survival. In December, when 3i Atlas emerges, the instruments will be waiting. Polarimetry, infrared mapping, photometric imaging, all ready to capture the first clear data on its shape. The moment it appears, every telescope will focus, every algorithm will run, every human eye will search for definition. Until then, it remains a silhouette behind the sun, formless, patient, and silent. A body that refuses to show itself, as though the very idea of structure were the secret it was built to keep. For months, the story of 3i Atlas has been shaped not only by what humanity could see, but by what it chose not to. The deeper the anomaly grew, the more the world's institutions seemed to look away, not from ignorance, but from fear of seeing too clearly. It is a strange kind of blindness, one born not from lack of data, but from an excess of consequence. Inside every agency, every university, and every private observatory, there is an invisible line dividing curiosity from caution. Cross it, and the questions become dangerous. Stay behind it, and the truth remains untouched. 3i Atlas has turned that line into a wall. The blindness began as protocol. When the object's anomalies first appeared, its chemical irregularities, its improbable orbit, agencies responded with textbook efficiency. Committees were formed, communication channels established, data sharing agreements drafted. Coordination, on paper, was perfect. But as soon as the data stopped fitting the models, the coordination began to fracture. Each institution retreated inward, guarding its own findings, tightening review processes, increasing the number of interim analyses that never reached the public. By late October, the collaborative spirit that had defined the early months of study had collapsed into silence. NASA, ESA, and JAXA stopped publishing real-time telemetry. The European Southern Observatory locked its shared database. The Arecibo archives went dark. What had once been a transparent global project devolved into compartmentalization. A dozen groups staring at the same mystery but refusing to speak to each other. Officially, this was to prevent confusion. Unverified information, they said, could cause panic or misinterpretation. Unofficially, it was self-defense. No one wanted to be the first to draw a conclusion that might later be proven wrong, or worse, proven right. There's an old saying in astronomy: the first observer of the extraordinary becomes its casualty. It's meant half as a joke, half as a warning. Discovery is celebrated, but only if it fits the framework. If it doesn't, the framework protects itself by burying the discoverer. Institutional blindness is not an accident of bureaucracy. It's a reflex of survival. Inside these institutions, that reflex now dictates everything. Requests for data are rerouted through layers of review. Memos about 3i Atlas require approval from multiple directors. Even internal briefings have been divided into need-to-know tiers. A planetary scientist at the Jet Propulsion Laboratory described it this way: "We're studying an interstellar object the same way intelligence agencies handle classified satellites, except the satellite might not be ours. It's not that the scientists themselves are unwilling. It's that the system they serve cannot process anomalies that threaten its architecture of certainty. Every agency is built around predictability. An unpredictable object becomes a bureaucratic virus. And so the instinct is to isolate it, not physically, but administratively, to keep it contained within language that neutralizes it. The result is absurd. The most significant interstellar observation in history is being managed like a public relations crisis. Committees issue statements carefully balanced between reassurance and opacity. No immediate cause for concern. Data remains within expected variance. Further analysis pending. These phrases are designed to calm, not to inform. They transform uncertainty into comfort. Behind that comfort, the blindness deepens. Some scientists call it the fog. a quiet pressure that seeps into every conversation. You can talk about the data, but not about what it might mean. You can discuss the chemical anomalies, but not the possibility of structure. You can mention the nickel signal, but only as a spectroscopic irregularity. The fog doesn't censor, it dilutes. Every word that could ignite wonder is replaced with one that extinguishes it. At a deeper level, the blindness is philosophical. Modern science is built on falsifiability, the idea that every claim must be disprovable. But what happens when the evidence can neither be confirmed nor denied? When the most crucial observations occur behind the sun, out of reach, leaving only ambiguous traces? 3. iAtlas has created a paradox of knowledge. Too much evidence to ignore, too little to conclude. In that paradox, institutions find safety. If the truth can't be proven, it can't be blamed. Still, cracks in the fog are appearing. Independent researchers, those without funding to lose, continue to publish open analyses, often hosted on unmoderated platforms. Their tone is different. Curious, fearless, unfiltered. They treat 3iAtlas not as a problem to be managed, but as a question to be pursued. And yet these same individuals find themselves dismissed by the mainstream as fringe voices, their work labelled speculative. The irony is that speculation is precisely what science once celebrated. Now, it's what institutions fear most. There is a deeper, more uncomfortable truth behind this blindness. It isn't just about funding, politics, or credibility. It's about power. For decades, astronomy has existed in a fragile balance between openness and control. Data from major observatories is technically public, but access depends on affiliation, approval, and timing. In theory, the sky belongs to everyone. In practice, it belongs to whoever holds the keys to the servers. 3iAtlas has made that imbalance visible. The world can see the sun, the planets, and the stars, but not the numbers that define this one object. The blindness is institutional, yes, but it's also collective. The public has been taught to trust authority, and authority has been taught to protect itself. Between them lies a void where understanding should be. In private, some scientists whisper about what might happen if the data were ever leaked. Would the world react with awe or panic? Would the revelation unify or fracture? The truth is they don't know, and that uncertainty terrifies the very people who built their careers on reason. Institutional blindness becomes a shield, protecting humanity from a reality it might not be ready to face. The effect of this silence is measurable. Interest in 3iAtlas has spread far beyond the scientific community, bleeding into politics, philosophy, and culture. Documentaries speculate, religious leaders comment, governments draft talking points. The absence of answers becomes its own form of presence. Every blackout of information feels like confirmation of something extraordinary. The institutions, in trying to contain the unknown, have instead magnified it. Somewhere deep within those institutions, a handful of people must be watching the unfiltered data right now. Engineers, analysts, astrophysicists bound by non-disclosure agreements. They are the only ones who know what 3iAtlas truly looks like at this moment behind the sun. They might already have seen it brighten, shift, or remain perfectly still. But their silence is total. There's a cruel symmetry in that. An object that may or may not see us has been hidden by the one force we can't escape, the sun, the very source of our sight, and in its absence our institutions, built to illuminate, have chosen to close their eyes. In the coming days, as the object emerges again, those eyes will have no choice but to open. The blindfold of caution will meet the light of observation. What's seen then will either justify every layer of control, or dissolve it. And when that moment arrives, humanity's ability to see clearly will depend not on telescopes, but on courage. It's almost time. After 47 days of silence, 47 days of speculation, and 47 days of waiting for the sky to speak again, the world is about to find out whether 3iAtlas survived. December 15th, the date circled on every mission calendar, printed on every telescope schedule, whispered in every scientific briefing, is now hours away. And across observatories, labs, and control rooms, a quiet tension hangs in the air. For the first time since October, the geometry of the solar system will align in humanity's favour. Earth, the Sun, and 3iAtlas will form a near-perfect line, an alignment so precise it feels deliberate. When it emerges from behind the Sun's corona, the object will cross back into visible space, and every instrument capable of sight will be watching. If there are answers, they will come now. The preparation for this moment has been immense, almost obsessive. Every major telescope, Hubble, Webb, Subaru, Keck, the Very Large Telescope in Chile, the Gran Telescopio Canarias in Spain, has dedicated blocks of time to the event. NASA's Parker Solar Probe and ESA's Solar Orbiter, still positioned near the Sun, have been recalibrated to track plasma fluctuations that might betray the object's re-emergence before it's even visible. The Deep Space Network is on standby to scan radio frequencies within the nickel emission band. The campaign is unlike anything astronomy has ever attempted. Hundreds of observatories, spread across continents synchronized by atomic clocks, all focusing on a single point in the sky. It's not just science, it's choreography, a planetary act of collective observation. Inside control rooms, the mood is strange, a mix of fatigue, excitement, and quiet dread. Scientists who've spent their careers studying distant stars now find themselves pacing like surgeons awaiting a patient's pulse. Some whisper superstitions about coincidences, about timing, about fate. Others bury themselves in calibration code, pretending the numbers might protect them from whatever truth appears. No one says it aloud, but everyone knows what's at stake. If 3i Atlas reappears exactly where predicted, unchanged, it will confirm the naturalist model. It will mean that every anomaly, its nickel emissions, its symmetry, its improbable orbit, can be explained by the universe's chaotic creativity. But if it reappears even slightly off course, if its trajectory, spin, or brightness deviates beyond expected error, it will mean that something acted upon it while it was hidden, something we didn't see, something that shouldn't exist. The first observation window opens just before dawn in Chile. The sky there is perfectly clear, the air dry and still. In the high-altitude control center of the Very Large Telescope, a team of 12 scientists sits before a wall of screens, waiting for the automated sequence to begin. Their instruments are pointed just above the horizon, near the solar glare. They won't see it directly at first. They'll see the space around it, the scattering of particles, the faint distortions in solar wind, the shimmer of heat, bleeding into the void. Then, as the sun dips low enough, a faint pixel of light appears where there was nothing before. It flickers once, twice, then steadies. Someone whispers, "We've got it." The room doesn't cheer, it exhales. Simultaneously, thousands of kilometers away, telescopes in Spain confirm the same point of light, faint but sharp, exactly where models said it would be. Within minutes, data begins to flow. Spectrometers engage, recording wavelengths, temperature, brightness. In a control center in Maryland, a NASA director stares at the incoming telemetry, numbers cascading across the screen like heartbeat monitors. The object is back. At first glance it looks normal. Its brightness curve matches projection. Its color remains the same, pale blue-white, nickel-rich. The orbit appears intact. Relief washes through the networks. Analysts send cautious messages. No deviation detected. Trajectory nominal. The tension begins to break. Maybe it was all just physics after all. Then, about 40 minutes into the observation, something subtle shifts. The nickel line, 341 nanometers, begins to fluctuate. At first, it seems like noise, atmospheric interference. But as more instruments confirm it, the fluctuation sharpens into rhythm. A pulse. 73 minutes between peaks, the same interval as before. The nickel signal has returned. No one says a word. The room that just moments ago was humming with relief falls silent again. Across continents, on secure conference calls and internal channels, the same realization is spreading. The object has emerged unchanged. The pattern survived perihelion intact. If the modulation were caused by sunlight, it should have vanished under such heat. If it were random, it shouldn't have repeated at all. But there it is, steady, measured, precise, like a metronome keeping time in the dark. ESA's solar orbiter detects something else, a localized magnetic distortion, oscillating in sync with the optical pulse. It's faint, but unmistakable. The object isn't just reflecting light, it's interacting with its environment. Its magnetic footprint beats in rhythm with its spectral signature. Parker Solar Probe, passing near the same region, records a similar disturbance in solar wind density. a ripple travelling outward every 73 minutes. When cross-referenced with Webb's infrared data, the timing aligns perfectly. Multiple instruments, multiple wavelengths, one pulse. By the end of the day, the coincidence has become impossible to deny. It's not an instrument glitch. It's not sunlight. It's not chance. Something about 3i Atlas oscillates with intention, chemical, magnetic or otherwise, and yet the official statements remain composed. NASA releases a brief notice. Object 3I/2025R2 Atlas successfully reacquired post-conjunction. Initial data consistent with prior observations. Further analysis ongoing. That's all. No mention of modulation, no mention of magnetic rhythm, no mention of what every scientist on those networks now feels in their bones. That whatever 3i Atlas is, it chose consistency. That night, as data streams pour into supercomputers, analysts begin comparing before and after measurements. Something else emerges, another pattern, more subtle. The object's rotational period appears to have shortened by about 2%. Not much, barely above error. But it's measurable. Statistically, that shouldn't happen naturally. Thermal expansion would slow rotation, not accelerate it. The change implies internal redistribution, mass movement, energy exchange, or deliberate correction. Some scientists, exhausted, refuse to believe it. It's noise, they insist, calibration drift. Others sit in silence, watching the graphs overlay. The lines are clear. The numbers are real. 3i Atlas did something behind the sun. Something it shouldn't have been able to do. Across the planet in dark observatories and fluorescent control rooms, screens continue to glow with live data. The pulse continues, unwavering. Every 73 minutes, a flicker of nickel light rises and falls in perfect time. It's not communication, not in any human sense. It's not language, but it's rhythm. And rhythm, in a cosmos defined by chaos, is a statement. It says, I am still here. By dawn on December 16th, the scientific community finds itself back where it began, staring at a phenomenon too structured to ignore, too ambiguous to define. The data confirms everything and explains nothing. The December test, once meant to settle the debate, has instead deepened it. The naturalists point to stability, proof of resilience, not intelligence. The technogenic theorists see the repetition as intent, a system maintaining equilibrium by design. Both sides claim victory. Neither can prove it. As the object drifts farther from the sun, its light begins to fade again, but the pulse continues, carried on wavelengths invisible to the naked eye. The instruments record it faithfully, cycle after cycle, as if 3i Atlas were marking the passage of time itself. In the end, the December test has done what every true discovery does. It has broken the frame of certainty. The world now sees 3i Atlas not as a question of science, but as a mirror of understanding. It reflects how we face the unknown, with wonder, with fear, with control, with silence. Somewhere out there, beyond the glare of the sun, the object continues its slow departure, indifferent to what we think of it. Maybe it's just rock and metal, a relic of cosmic chance. Maybe it's something else, something that once had a purpose still following its last command. Either way, the test is over. And the silence that follows feels heavier than before, not because nothing happened, but because something did. By dawn on December 17th, the numbers were undeniable. The modulation persisted. The magnetic field oscillations aligned perfectly. The trajectory remained precise, its orbital curve unchanged within measurable limits. No explosion, no fragmentation, no deviation, just that same steady rhythm. Every 73 minutes, a rise and fall in nickel emission, as constant as the ticking of an unseen clock. And with that, the question that has haunted the world since its discovery rose to the surface again. Is 3i Atlas a natural phenomenon, or something designed? The divide isn't just scientific anymore, it's philosophical, cultural, even existential. The data itself is neutral, it doesn't argue. But the interpretations built upon it are dividing people in ways data never should. Because how one explains 3i Atlas says less about the object and more about who we are, how much order we believe the universe can produce without guidance, and how much mystery we're willing to let exist without a name. In the official press briefings, nothing changes. NASA's statements remain dry, precise, inert. 3 I/2025 R2 Atlas continues to exhibit stable emission features. ESA echoes the same tone. No evidence of external propulsion or non-gravitational influence detected. The key word, as always, is evidence. Absence of proof masquerading as proof of absence. The subtext is clear. There is no official mechanism for declaring a discovery like this designed. The system cannot accommodate intent. But inside the private message threads, the tone is different. Scientists who have spent their careers dismantling superstition now find themselves whispering about symmetry, timing, and control. The older ones dismiss it as coincidence polished by imagination. The younger ones see something else. Pattern. They're used to thinking in probabilities, and the probability that so many independent anomalies, chemical, thermal, orbital, rhythmic, could align by chance now feels vanishingly small. Two models remain on the table. The first, the natural synthesis hypothesis, tries to preserve the familiar laws of the cosmos. It describes 3I Atlas as a frozen chemical reactor, a relic from a rare stellar nursery where metallic condensation and magnetic turbulence forged a body capable of self-regulation. The periodic nickel emissions, it claims, are resonance patterns from a crystalline core oscillating under solar heating, beautiful, complex, and entirely accidental. The second, whispered under the radar, is the technogenic residue hypothesis. It makes no claim about intelligence, only engineering. According to this model, 3I Atlas could be a fragment, perhaps debris from a structure or vessel, whose systems, though long dead, still function as physics. Resonant fields maintaining balance, automated stabilization long after purpose was lost. In other words, not a machine that's alive, but one that remembers how to behave as if it were. Both models fit the data, both contradict each other. At the University of Toronto, a team of dynamicists analysed high-resolution photometry from the Very Large Telescope and found something small but profound. Tiny fluctuations in brightness that repeat not just every rotation, but in pairs, mirror pulses offset by exact fractions of their period. In mathematics, that kind of mirroring is called bilateral symmetry. In biology, it's a hallmark of design. In astrophysics, it's nearly unheard of. The team avoided those words in their paper. They wrote instead, observed photometric symmetry exceeds expected stochastic distribution, which is another way of saying nature doesn't do this often. Meanwhile, an internal report from the Parker Solar Probe hinted at something even stranger. A faint trace of ionized nickel particles moving away from the object at near constant velocity, unaffected by solar wind variations. The direction of that flow aligned precisely with the object's spin axis, like exhaust or a controlled vent, yet the force generated by that emission was negligible, far too weak to change trajectory. It was motion without purpose, repetition without result, like breath. The naturalists say it's venting, simple sublimation. The technogenic camp calls it maintenance, an old process running on instinct. The arguments have begun to take on theological tones. One side sees randomness refined by physics into illusion. The other sees evidence of forgotten order buried in dust and metal. Neither can disprove the other. The truth balances between them like a pendulum, swinging to the rhythm of that same 73-minute signal. Outside academia, the debate has escaped into the world. News anchors speak of the interstellar clock. Commentators on talk shows ask whether humanity would recognize intelligence if it were mechanical and indifferent. In universities, philosophy students write essays comparing 3I Atlas to Plato's cave. Light patterns misread as meaning. In temples and mosques, some call it a sign, while others call it a test. Everyone seems to agree on one thing. Whatever it is, it feels intentional. That feeling is dangerous because feeling isn't data, but neither is it nothing. Humans have always given meaning to rhythm. Drums, heartbeats, tides, all motion that repeats invites interpretation. The nickel signal is no different. It repeats, so we listen. It's steady, so we assign it purpose. The question is whether that instinct betrays us or saves us. In private, several prominent scientists have confessed unease. One of them, a senior researcher at ESA, wrote anonymously in a closed forum, "If this is natural, it's the most beautifully disciplined accident in the observable universe. And if it's not, we have no framework for what that means." Another replied, simply, "Maybe we don't need one yet. And maybe that's the point. The argument over natural versus designed isn't really about the object, it's about readiness. Every civilization reaches a threshold when observation outpaces comprehension. Ours may have just crossed it. The instruments have become so precise that they now return data stranger than belief, and the institutions interpreting that data still rely on the language of certainty. 3i Atlas lives in the space between those two realities, a riddle too advanced for our vocabulary. When the first data from the re-emergence was shared across networks, the scientists who saw it in real time described a moment of collective stillness. It wasn't awe, it wasn't fear, it was recognition. They didn't see technology, they saw control, a system that maintains equilibrium, not for survival, but because it must, as if following a rule written long before intention existed. Perhaps that's what separates natural from designed, not who made it, but why it endures. Nature decays, machines persist. 3i Atlas, after all this time, is still holding form, still emitting in rhythm, still orbiting as if guided. That persistence, whether born of physics or memory, is what makes it feel alive. By December 20th, the news has already spread worldwide. The nickel signal is confirmed, verified by independent observatories in Japan, Chile, and South Africa. Every 73 minutes, without fail, the light rises and falls. The graphs are everywhere now, shared on screens, printed in newspapers, looping endlessly on social feeds. People who don't understand spectroscopy can still see the pulse and feel what it means. Something out there is moving with precision, something that shouldn't. But precision is not proof. The naturalists remind everyone that order emerges all the time. Snowflakes, crystal lattices, pulsars, and molecular rings. Nature writes in symmetry too. Maybe 3i Atlas is simply another snowflake drifting through cosmic sunlight, its edges sharper than usual, its rhythm carved by coincidence. Maybe. And yet, the thought lingers. If it is natural, why does it look so much like intention? And if it is designed, why does it hide so well within the language of nature? No one can answer that. All they can do is measure. The instruments will continue tracking it until it fades from sight, months from now, when it finally slips back into interstellar space. Then, 3i Atlas will become a memory again, a ghost of data stored in archives, waiting for someone decades from now to reopen the file and see the pulse that no one could explain. For now, the debate continues: natural or designed, chaos or control, coincidence or code. The words circle endlessly, chasing an object that never speaks, only repeats. Somewhere out there, far beyond the warmth of our star, a faint blue light flickers in rhythm. Not speaking, not calling, not answering, just keeping time. And perhaps that is the answer. Not a message, but a mirror. 3i Atlas shows us what we do when faced with the inexplicable. Some explain, some deny, some fall silent, but all in their own way, listen. In the aftermath of the December re-emergence, as data streamed in and debate turned feral, something became painfully clear. Humanity had no plan for this. No law, no protocol, no defined authority was equipped to decide what happens when a discovery refuses to fit inside our categories of natural or artificial. The object called 3i Atlas has done more than challenge physics. It has exposed the vacuum above science, the silence in policy, in governance, in preparation. The last official framework remotely relevant to an event like this dates back to the late 1960s, written in an era when the moon was still theoretical territory. The Outer Space Treaty defined ownership, not ontology. It established who could claim celestial bodies, not how to interpret them. It was written for competition, not contact. Decades later, the Declaration of Principles concerning activities following the detection of extraterrestrial intelligence as drafted by the International Academy of Astronautics tried to imagine what we might do if we found a signal. But even that document assumes clarity, a message, a source, a decision tree. It does not account for a silence that pulses, for an object that might be the signal itself. And so, in December 2025, as telescopes confirmed rhythmic emissions from a 60-kilometre metallic body crossing Earth's orbital line, the question no one could answer was suddenly unavoidable. Who decides what this means? Inside the United Nations Office for Outer Space Affairs in Vienna, emergency meetings were quietly convened. The agenda sounded procedural. coordination of interagency responses to interstellar observations, but the atmosphere was anything but. Representatives from spacefaring nations joined by secure line, their screens darkened, their words measured. They weren't arguing about science, they were arguing about jurisdiction. If 3E Atlas proved to be more than inert matter, if its behaviour implied construction, design, or the ghost of technology, then by definition it entered a legal void. Was it property? Was it heritage? Was it danger? NASA's liaison argued for transparency, claiming public trust depended on open data. The European contingent urged caution, coordinated release. China's delegation asked a question that froze the room. If it turns, who gives the command? There was no answer. The vacuum isn't theoretical, it's procedural. Space law was built around objects we send out, not those that come in. Asteroids, comets, even interstellar visitors were treated as resources or research targets. None of the treaties consider the possibility that one might display behaviour suggesting purpose, because the moment purpose is acknowledged, sovereignty collapses. Every nation, every agency, every scientist loses jurisdiction to something undefined. So, institutions improvise. In the days following the December signal confirmation, a wave of memos swept through space policy networks. Interstellar Object Contingency Review, Protocol Harmonization for Anomalous Phenomena, Information Release Coordination Directive. Every document said the same thing in different words. Don't move without consensus. But consensus requires leadership, and leadership requires courage. In the vacuum, committees fill the silence with process. Meanwhile, outside those meetings, information leaks in fragments. A French astrophysicist publishes anonymized telemetry showing synchronized magnetic pulses recorded across 5 observatories. A private observatory in New Zealand uploads high-fidelity images revealing faint, repeating surface reflections, like facets catching light at regular intervals. Within hours, the files are mirrored globally. Deletions follow, but the internet remembers. The leaks deepen the divide. Governments insist on restraint. Civil scientists call it secrecy. The public calls it proof. In an age where data moves faster than policy, the machinery of governance looks archaic, almost ceremonial. Rituals of control over realities it can't control. By December 22nd, the silence from official channels has become untenable. Pressure builds. News outlets demand answers. Politicians sense opportunity. On December 23rd, the United Nations issues its first joint statement. In response to recent astronomical observations, the international community reaffirms its commitment to cooperation, transparency, and peace in the exploration of outer space. It says nothing, but it says it together. That, for now, is the point. To look unified even as understanding collapses. Privately, scientists describe what's happening as the bureaucratization of wonder. For the first time in history, awe has become an administrative challenge. The data that should have ignited a renaissance in discovery is instead passing through risk filters and diplomatic channels. What began as curiosity has become policy management, and yet the deeper irony is that no one disagrees on the facts. Every agency has confirmed the pulse, the symmetry, the consistency. What divides them is not the evidence, it's the interpretation and the fear of being the first to define it. Because once defined, the world must react. In a secure NASA briefing dated December the 24th, an internal document titled Potential Technological Signatures, Interstellar Object Protocol Draft, outlines 3 scenarios. False. Positive. The pattern is natural. Result. Continue research. Maintain transparency. Unconfirmed artificial. Evidence suggests technological origin, but ambiguity remains. Result. Control narrative. Delay conclusion. Coordinate with allies. Confirmed artificial. Evidence exceeds reasonable doubt. Result. Immediate international council. Data restriction until assessment of risk and opportunity complete. The document ends with a phrase written in bold, communication protocol not yet defined. That sentence captures the void perfectly. If 3i Atlas ever did emit an unmistakable signal, if the pulse ever shifted into something structured, even simple binary, the world wouldn't know what to do next. There is no contact protocol at the planetary level. The responsibility is distributed, fragmented, undefined. And so, the response becomes silence dressed as coordination. The vacuum remains filled not with leadership but with waiting. But waiting has its own cost. In the absence of clear authority, new voices step forward. Private companies offer to assist with independent data verification. Think tanks issue white papers about interstellar technology readiness. Religious organizations announce days of reflection. In this vacuum, speculation becomes governance, and interpretation becomes policy. The world, for lack of answers, begins building its own. In a small but growing coalition of scientists and ethicists, calling themselves the Interstellar Object Readiness Network, a new idea is taking shape. They propose an international body designed for exactly this kind of uncertainty, a permanent, multidisciplinary council with authority to assess, interpret and respond to interstellar phenomena. Not military, not governmental, a hybrid of science and diplomacy. They argue that 3i Atlas is only the first. More objects will come, and if humanity cannot coordinate its perception of the extraordinary, it will fracture under its meaning. Their proposal hasn't reached the public yet. But drafts circulate quietly through the same networks that once hid the data. For the first time, the policy vacuum is being filled not by institutions defending their boundaries, but by individuals trying to redraw them. Still, the world outside remains in suspense. Governments reassure, scientists hesitate. Telescopes continue to track the fading object. Each pulse still arrives on schedule, like a heartbeat measured across cosmic distance. The difference is that now everyone is listening, but no one is leading. And maybe that's the truest reflection of this moment. 3i Atlas has shown us more than an anomaly. It has shown us our own structure, fragmented, cautious, improvising meaning in the dark. We have built machines that can see across light years, but no system that can decide what to do when those machines see too much. As the new year approaches, 3i Atlas drifts outward, leaving behind the echo of its pulse and the bureaucratic chaos it created. The data will continue for months, the debates for years, but policy as always lags behind wonder. And so, in the absence of a voice that can speak for humanity, the universe continues speaking in its own language, light, rhythm, and silence, while we argue over who has the right to listen. In the end, 3i Atlas left us exactly as it arrived. Silent, precise, and unwilling to explain itself. It came from nowhere we could name, moved in ways we could barely predict, and disappeared back into the dark, leaving behind only numbers and a feeling that something had just brushed against the edge of human understanding. The debates will continue, natural or designed, coincidence or control, but they no longer matter as much as what the object revealed about us. Faced with an intelligence we could not confirm or a pattern we could not dismiss, we built stories to protect ourselves. Some sought comfort in physics, others in faith, and some in silence. But all of us, in one way or another, looked up. For a brief moment, the world shared a heartbeat with something vast and unknowable. We measured it, argued about it, feared it, and then, when the light finally vanished, we missed it. Perhaps that's the truest legacy of 3i Atlas. Not proof of anything beyond us, but the reminder that mystery still exists. That even in an age of perfect instruments, the universe can still speak in riddles we're not ready to solve. It's still out there now, somewhere beyond Jupiter's path, its pulse fading into the cold between stars. No signal, no message, just a rhythm written in light, keeping time in the dark. And maybe, long after we're gone, that rhythm will still be there, a silent record of the moment when humanity looked at an object from another star and realized that not everything that moves toward us comes to be understood.